Good morning. Appreciate everybody coming in and zooming in and looking at this recording in a future date. This is ECOS, Electric Culture of Safety. This is episode 066. This is the beginning, March the 13th of our third year into Electric Culture of Safety, now with over 14,000 partners around the United States and Canada. And so appreciate y'all being here. This is a grassroots safety coalition that we started about 3 years ago last month. And it's been an amazing ride what's going on. But what we're going to do is Brent Jeffries, Bierer Meters, Vice President of Field Operations and Safety Instructor, also the founder of ECOS, Electric Culture of Safety. And we'll get more into that in just a minute. But Bierer Meters, it's been a great ride as far as training linemen around the United States for about 9 years now, going into 9 years. Coast to coast, corner to corner, even into Canada, a little international, and training thousands of linemen around the country. What we call our Lineworker safety tool competence is what you're getting today. And there's a lot of information here, and it's going to be you're going to hear things that you haven't heard before. And you all are welcome to ask questions. This is an open forum, which I allow wherever I go. You can interrupt, ask questions. There's the opportunity. You can type in on that Zoom link, and Mr. Jeremy, our videographer, he'll relay them back to me. So please ask questions, and I'll actually ask you all a couple of questions as well. So we'll be looking for some answers from you all. So this is interactive. This is how we do it. It's hands-on. As you can see, the tools all around us. So it's hands-on, and I like to get some folks involved with this. This is session 1 of what we call our Lineworker Safety Tool Competence Workshop. And this is session 1 of 3 sessions. The workshop is an all-day experience, unique in our industry. We take care of 2 indoor classes, totally separate, totally unique. Indoors in the mornings, we break for a lunch, and then we take the 2 sessions, everything we learn, and we apply it in the field outside, and we practice what we learned inside. So it's hands-on, and then we go live line on the outside. A lot of folks are catching on to this and taking advantage of it. Bierer Meters, we don't charge for what we share. This is us giving back to you all, and it's an amazing ride. So Bierer Meters, we've been in business since, 87? Can you believe that? 87, right here in South Carolina. We actually have our tent in our live line training center. There's some energized, well, it's de-energized now, but we have overhead, underground, all kinds of equipment behind us. And so we do a lot of live training here. Webinar training, we have folks coming in. We even had EPCOR from Canada coming in and doing training with them. So we have folks coming in all the time. So you're welcome to take advantage of this and come on in, set it up. My brother Joe Bierer and my nephew Ryan Bierer, they can do this training. I typically do the Lineworker Safety Tool Competence and the other sessions around the country. So I don't typically do the ones here at the yard. But our place here, our factory is right here. We make everything, Bierer Meters, we make everything from scratch. Walter Bierer, my dad, he's the owner of the company, and he has 17 patents. So we have more patents than any of our competitors combined, and all of them combined. So it's an awesome thing what we do. And just real quick, we'll come back to this at the end if you all want some more information, but we make the best, strongest products, durable products, robust for linemen, accurate, wireless phasing tools, phasing ranger. We can phase anywhere on your grid with just a cell phone. And our phasing ranger kits, the ST800, the best service tester around. And then we have our single phase ID. We can ID cable. We have a 3-phase ID, and we can ID cable. So we have the best products. Our wireless phasing voltmeter, 2 functions. You can look at your wave, your sine wave, and it'll pick out what phase you're on. If it's a match or not a match, it'll declare if it's an ABC as well. And you can use it as its second functionality as a voltmeter. So 2 functions. We have the pole guards, best plastic in the industry, flat out. We also have, my brother invested hundreds of thousands of dollars, and we have our own clamps, and we'll get into our own cable, our own, this is duckbill. We have C clamps. I think he has 22 different clamps now, and our own ferrules. So we have obviously our own customized TPGs, customized for your specifications. So these are pretty nice clamps. Also check out, if you get a chance, you go to our website, bierermeters.com, and you can download the PDF of our brochure, brand new brochure. We just came out with this back in January this year. And it's all interactive. It's got QR codes as far as how to use the tools properly from Bierer Meters YouTube channel. And you all are welcome to subscribe. We have over, I think, 300 videos now, safety training, tool training videos on bierermeters.com, and it's a great resource. But this here brochure gives you a lot of information of all of our products. So we also have a Bierer USA, which is Bierer Utility Support Assistance. And this little handout, 6-page trifold, this here goes over everything we do out in the field for you all at no cost. Field training, we do webinar training, we do tool methods, work method meetings. We actually come and we present safety presentations all around the United States at your annuals, statewide annuals, incident prevention conferences, NECA. We do all that. And again, we don't charge anything. All right? So it's pretty neat. Get some of this information. Hard hat stickers right here, Bierer Meters. You got electric culture of safety as well. We have hats. You can go to that brochure, and we have some swag, beer swag. These hats here, we sell them at cost. When I travel, I can give them away, but we got them on our brochure, and they're at cost. I think they're like $25 something Richardson, but we got the black camo, and we have the bottomland camo. Nice hats. And we have a few left of our 2024 International Lineman Rodeo. I think we have 70 or so left. And the theme of last year's International Rodeo, the theme is, what is the theme? It is the perfect job brief. And as you can see here, the line workers are gathered around. And the reason why we called it the perfect job brief is because there really is no perfect job brief unless you're connected. If you're a line team, then it's a perfect job brief. You got to come together. And you can see the International Linemen's logo right here. They let us use it because we gave out like 500 t-shirts. And this sleeve here. It's brushed cotton, comfy. I'm actually wearing underneath here. It's really nice. So we're going to get into our line worker safety and tool competence presentation now. So we're going to change gears, and you all can contact me here, right here. You got safety training at bierermeters.com. If you're watching this, you could actually put Brent at bierermeters.com, and you'll reach me there. Okay, so just put Brent. So you'll see some pictures coming up, and these are pictures of just training out all around the United States. Here's a little PG&E action. That was a really great training. Kind of hot that day, but it was good. All right, and here's the intro real quick to electric culture of safety is what this is all about, right? What you're getting. And you can see all the folks that have given us their logos. They partner up with us. And we have, again, over 14,000 partners. And it's an amazing thing what's going on here. And we have the website, electriccultureofsafety.com, and we're downloading more and more of our ECOS Livewire, the full episodes, and more of the full line worker safety national webinars, which is, this is 066, and this is going to be fun. All right. So here's a little video clip, a little quick introduction of what this is all about from a lot of the speakers that have come here.
Why is this happening? It hurts. Am I going to die today? These are thoughts that flash through my mind as induction from two 500,000 volt circuits surged through my body for roughly 30 seconds. The day that we planned on just doing our daily work, bare hand project. We've done it 100 times before this. Never thought twice about how the day would go, and this day was different.
If we practice for the event, we may not have to practice for the funerals. So that's from here, you guys. I'm not trying to bust your balls. That's what's really happening. This is what a lineman funeral looks like, and you don't want to go to one.
Don't think we're talking about leadership and executives and all that today. This is about you and I. This is about you and I, you and your family, all right? You need to own your safety, all right? Only you can have a positive effect on other people. You can also have a negative effect on other people, all right? But why? Why would we want to do that? Why would we not want to win the crowd? Why wouldn't we not want to build a successful culture? It's up to you and I.
When you get up in the morning, I want you to look yourself in the mirror, and I want you to verbally tell yourself, I'm going to save a life today. And I want you to do that each and every day. And when you come home at night and you get ready to retire and go to bed, you look in that same mirror and you ask yourself, did I do my number one task? Did I save a life today? And take stock, because there's nothing more important. We've all got tasks to do, but that's the most important thing that we can do.
And then I talk about this from a decision-making standpoint. These leaders have to be able to make decisions on the fly. And honestly, they have to be able to do this. Stop the job now. They have to make these decisions, and we have to empower them to make these decisions. This is such a strong duty that we just can't roll over.
I'll just summarize. Again, lead and protect people rather than managing robots, policing systems. Realize that hazards and risk are quantifiable and predictable. If we can predict, we can prevent. Make sure that we're focused more on self-reliance than over-relying on other people and things like protective equipment to protect us. And then use the hierarchy of controls. It works. It works. It doesn't work real well if we just settle, if we just start with PPE. It works really, really well if we have a conversation and really think about, for this task, how can I protect myself? And so I will again close by thanking Brent and Bierer Meters for the opportunity to be here. ECOS, the electric culture of safety. Get involved with that. I love what they're doing. So honored to be a very small part of it. Honored to be here today. And everybody, take what we've talked about today to heart. It doesn't do any good to talk about it and listen to it in a virtual format or watch a recording of it or see it up on the screen. It does a heck of a lot of good when we apply it in the field. So turn the words to action. Stay safe. Be well.
It's pretty neat having these folks. Their companies sponsor them to fly them out, or they drive out, and then they share a presentation, a topic of their heart. I let them choose. They choose exactly what they want to share with you all. So it's an amazing thing what's going on here. So what's happening is, as we form this line team nationwide, is we are all coming together and we're all giving back to our most awesome trade. So it's a neat thing. So we're going to get started. Y'all ready? Remember, this here is going to be open forum. Please ask questions in the chat room. Mr. Jeremy, just type them out. Mr. Jeremy will get them back to me. All right? So here we go. We're going to talk about protective grounds, your temporary protective grounds. These are to be considered a best friend. We're going to talk about two best friends here today. Your TPGs are one of your best friends. So we got to take care of these things. So we're going to get into this, the OSHA rules, some regulations here. And these OSHA regulations, these need to be considered just the foundation. Only the foundation of what we're going to build here today is a house of safety. That's what we're doing together. All right? We're going to build a house of safety. And how we build that house is we take the regulations and you add training. You're going to take the regulations and you're going to add communication, you're going to add leadership skills, you're going to add capacity. You're going to build in capacity to fail safely. And we're going to look out for each other. And as long as we do all these things, looking out for each other, what happens is you build a house of safety. And that house of safety is going to endure, as long as we're together, that house of safety is going to endure any hurricane, any storm, even tornado. Basically, we're going to make a tornado shelter as well in this house of safety. Okay? That's where we go, man. We're going to go there and we're going to dwell there. All right? So that's what we do with these regs. So your temporary protected grounds, we're going to just look at this real quick. Protected grounding, equipment shall be capable of conducting the maximum fault current that could flow at the point of grounding for the time necessary to clear the fault. This is at a 1910.269. This is going to be the lowercase n. Lowercase n is all about your TPGs. All right? So remember that. And it's good to review these together as a group, as a team. Protected grounds shall have an impedance low enough that they do not delay the operation of protected devices in case of accidental energizing of the line or equipment. All right, so basically, OSHA is talking about protecting the system, protecting the equipment, protecting the system. That's going to be your what? The thing is with OSHA is they do not talk about the how and whys. They do not. They just talk about the what. So it's up to us to share and to communicate the how and whys behind the what. Okay? Real simple. And that's what we got to do. And if somebody doesn't understand the how, if they don't understand the why, we've got to be patient until they get it. And once they get it, they'll never unget it. So that's really important. Let's work together on that. All right, so what we're going to do is we're going to talk about your TPGs and your A best friend, and we're going to go to our grounds tester to do that. When you go to that lowercase n, you go to number 4, and you go to the lowercase I, triple I. It talks about how the ASTM F855 and the IEEE 1048, it talks about how they are guidelines to the regulations. So we're going to talk about those guidelines. And in those guidelines, it talks about mechanical inspection. It talks about visual inspection. So we're going to go over that. And it also talks about electrical inspection, which we're going to finalize with that right there. Okay? So what we're going to do is we're going to take our TPGs, temporary protected grounds, which this happens to be a Bierer Meters cable that we make, and our clamps, our ferrules. Beautiful. This is a 1/0, 10 feet. So what we're going to do is we're going to visually inspect. When we visually inspect, we're going to verify that there's no smashed cable or crimped cable. If you can see your strands, we do not want to see any blackened strands, patinaed strands, or broken strands of cable. Some of you may have some clear jacket on your cables. And if you have a clear jacket, inspect those strands inside that clear jacket. You also don't want to see any oxidization on your components, especially the contact points right there where that clamp's going to go onto that conductor, especially the contact points. You don't want to see any obvious loose parts nor any cracks in your clamps. So verify that. You don't want to see any bubble jacket either. I have never seen the bubble jacket, but I have seen everything else. Loose components, broken strands, blackened copper, bent components, and I've seen a lot of the oxidization on the contact points. And that's all those things add to resistance. They add to thermal activity. They add to the fact that, guess what? Their TPGs aren't going to perform as well. And typically, if you start seeing these items, as far as the things you don't want to see, these are where they're going to fail the electrical test. So, train your linemen to do the mechanical, to do the visual, And you all are responsible for the electrical test. They don't give us, the guidelines do not give us how often we need to perform the electrical test. I don't understand that, but we recommend every 12 months. 24 months, some folks do, too long. 6 months, if you're training your line workers to perform the mechanical and visual, 6 months is too often. It's a waste of resource. Train them to visually inspect. Train them to mechanically inspect. And you don't have to do the 6 months. As long as they know what they're looking for, save some money, but train them. All right, some utilities, some contractors, believe it or not, to this day, they do not train their linemen the visual, the mechanical, and check this out. I don't understand this, but some do not perform the electrical test on their TPGs. Don't understand. We're supposed to verify that those two TPGs are going to perform if there's a fault current. How do you verify that you're sure for sure, as an employer, that those TPGs are good? How do you do that unless you perform the electrical test? I don't know. If you all have the answer, please tell me. All right? That'd be great. So what we're going to do is the mechanical test. You want to go ahead and grab a hold of your TPGs. You want to grab a hold of that clamp and make sure that that clamp does not spin off your ferrule. Make sure if it's a plug ferrule, make sure that plug is nice and tight in those U-joints. U-joints, I think that's a car thing. But in the U-clamps, okay? So make sure they're nice and tight. I've performed electrical testing on TPGs and they have barely failed, and the visual, they pass. But the mechanical, the clamps spin right off of the ferrule. What the heck, huh? And all we did is get a wrench, tighten it up, retest electrically, and guess what? They pass. It's like magic. All right, so we're going to perform electrical test. And what we're going to do is this 1/0 cable, 10 feet, it requires 250 amps. So Bierer Meters, my dad, Walter Bierer, he came out with the grounds tester. This is his very first tool. Back in 1987, he came out. And when he made this tool, just like the rest of our tools, he developed a tool that was the best of the best. And this tool puts out continuous current. Everyone else is chasing us, trying to emulate and try to copy. Most of them are glorified ohms meters, but they're trying to get that continuous current. Well, Walter, he did that a long time ago, all right, back in 1987. So here we go. We're going to go ahead. It requires 250 amps. We're going to put right here on the continuous current meter, we're going to put 250 amps, and we're going to run these in parallel. This mitigates the magnetic field, and this also represents how you're going to use these out in the field. You're going to go from point A to point B when you set up your EPZ, equal potential zone, to help protect you all when you're working. So this emulates that, it copies that, and we're going to get rid of any magnetic field. So we're going to go up to right here, 250, and I can feel the current in my hand right now. And it's a little exciting. Maybe you travel and been away from home for a while, all right? And this gets kind of exciting when you feel that current. So we got a 0.27. It requires a 0.38 or lower voltage drop. These pass pretty well too. So it's going to pick up some voltage drop, which is your resistance, just because that's how things work, right? So I want to show you. So these pass. The test is over. So what you're going to do is you're going to undo the clamps, and you're going to put a date stamp. And that date stamp, the line worker, when they perform their visual inspection, they're going to verify at that date stamp that's on your TPGs that it's in the protocol of when they test, let's say every 12 months. Maybe they're out on a storm, out on restoration, and they got skipped. So this allows them to verify that they're within those 12 months. All right? It's very important, date stamp. We recommend also, you have some folks that do these tools or do the testing on your TPGs. Maybe it's an outside source. Make sure they're using a really good grounds tester. It's so important. Some folks test grounds multiple grounds after multiple grounds, and they're glorified ohms meters. Guess what? If you compare how theirs test and then retest with ours, a lot of times ours will find the issue that theirs did not. So make sure, ask them what product are they using to test your grounds, or do it in-house, man. Just do it in-house. We train your guys to test grounds. They're really easy. A lot of utilities do it. Contractors, they do it. So what we're gonna do is we got a magnet in a bottle, all right? And right here, this is gonna prove your electric reality, and we're gonna look at that magnetic field right here. And you can see that hum? That's a humdinger, all right? Nice and smooth. And that, you see some magnetic field, but watch what happens. We're gonna form some loopage, which when you're using your TPGs, you do not ever wanna have loopage. Coils. What happens, coils, like a transformer, stepping up, step down, whatever. What happens is that increases, that magnifies the magnetic field. So when you're using your TPGs, if they're on a truck reel, man, make sure you get that truck reel, get your TPGs all the way out, lay them parallel on the ground, but get them off that truck reel. Don't allow those coils. Maybe your TPGs are too long, and you think that if you coil them and get some electrical tape and hang them, creating your EPZ, maybe that looks nice. No, don't want any coils. Don't do that. Okay? So here we got some coils. Same test, all right? We're very scientific here. This is line work. Look at that. Y'all see the difference? This is exactly what you don't want. That's a magnetic field going crazy. You don't want that. Make sure you don't have them in coil anywhere. I've done the training where we're outside. We did the inside training. The guys are grounding their bucket truck, and we're at a substation, and I'm seeing a couple of coils on the ground. And it's like, hey, guys, before we get started here, before we get all involved in this work, let's review and remember what we learned in the sessions previously before we got outside. Check out those grounds. And it's like, oh, yeah. So they'll straighten them out. Run them in parallel, all right? Not coiled. Any questions at all? Jeremy, do we have any questions? Not yet? Okay. If you have questions, put them in and type them. Okay, so we're going to change gears now. The battery test. This is important. I want you all to always test your batteries. Now remember, this training, Lineworker safety and tool competence, this training is non-bias. So you can use Bierer Meters tools. That's great. That's what we want to see, and that's what we want to hear. But if you're using another manufacturer's tools, all this training that you're getting here today is the same. All right? It applies to the other tools as well. It's the principles. It's basically, we're proving your electric reality. We're not going to talk about theory today. And that's why it's so cool about our tools, is because our tools are so accurate, they prove your electric reality. There is no theory. All right? So it's a good understanding. So battery test. Some folks, horn and lights, tick tracer, whatever, their battery test is a push button. Some folks tell them that, hey, you're going to have to grab your tool and you're going to rub it on your FR, create static. And that's the test, tool test. It's like, that makes no sense. It's not high voltage. Why would you try to get some static and make sure your tool's working properly? Does that make any sense? You're going to be working on high voltage and you're going like this? Huh? What the heck is that? So we don't want to do that. We're going to use live voltage. But anyways, the battery test. All we do in the battery test is we test the battery. That's all. Whether it's a push button or we have a switch plate. Okay? It's real simple. And we just go to the test position. So, test position, right there. You want to see and you want to hear your tool. If you do not see and hear, or just one of the others, then change out the battery. So you take your quick change, you go to your quick change, get your wrench, remove the quick change for your live line tool, your hot sticks right here. Hot stick adapter goes on that. Tap out your battery, replace that 9-volt battery. Lickety split. Make sure that 9-volt battery's a good battery. retest. If you still don't see, or you don't hear, or you don't get both reactions from your horn and light, audio, visual, then what you want to do is tag it, and you're going to ship it back to South Carolina, right here. We built it, so you're going to ship it right here, and we're going to fix it for you. No problems. If you need recalibration, we can do that too. Typically, we repair and we calibrate on all of our repairs, just to make sure before you get it, you're good. All right? So that's a horn and light. Analog. Analogs, again, you have your test position. All right? Maybe it's a push button. But there's no transformer inside anybody's voltage indicator or phasing meters that step up the 9 volts to high voltage. Nobody does that. It's going to be a lot of extra weight. So no one does that. It's just a battery test. And what you want to see is you want to see that needle. You want to see that needle move all the way. If it only is partial or it doesn't move, replace the battery. If it still doesn't move or it's just partial, again, you're going to ship it right here to our factory, Blythewood, South Carolina, and we're going to repair it. Easy, fast. Now, the digitals, I like the digitals better. 1, they don't have moving parts. 2, because they don't have moving parts, they're definitely more robust. 3, my favorite is they're more accurate. I like that. They give you 4, more information. So I like that. So case in point, we go to the test position and it gives you the battery voltage, about 8.9. Huh? That's more information. You didn't get that in the horn and light. You didn't get that in the analog. More accurate, more information. Because the digitals are more accurate, because they're more information, it is important to give, this is how I train when I go around the country. You want to give your linemen the absolute best. So we suggest that you phase out the non-contact tools, which are very dangerous, and we'll talk more about that in a little bit. You phase out the horn and lights. You phase out the analogs. Oh, you know, we've always used analogs. Yeah, I know. I'm about to retire, and all I am used to is analogs. I don't want to make a change. Hey, I tell you what, when you make a change and you see the difference, you'll never unsee the difference, and you'll be glad you made the change. Digital. All right? More information, a lot safer. There you go. So we're going to talk about proper device accessories, and we're going to talk about care. On your meter, regardless of manufacturer, you're going to make sure you keep that probe clean. We don't want to see any outside tracking. We don't want to have dirt. We don't want to have grease. We don't want to have calibration stickers. Maybe someone is so in love with their tool that they put truck number, blah, 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 lineman, da, da, da. Don't do that, all right? You can do all that on the housing. That's wonderful. Put all that on the housing. Hot stick wipes. Use a hot stick wipe. When you're done using these tools at the end of the day, wipe them down prior to placing them in your box for transit. Always keep them in storage, whether it's a bag, whether it's a phone box, always put them in storage. Protect the tool. Don't lay these in the truck as you're going back to the service center, your district center, and they start bouncing around in the bin with all the other things. Don't do that. Always store them so you keep them safe and sound. All right? We had some folks. I had a call to Colombia, South America, talking about buying our tools, and they're like, "Man, your tools are a little more expensive than these guys." And I said, "Hey, lower your price." I said, "Wait. We're not going to lower our price at all for you guys. Why? Because these housings were tested with a half-ton truck driving over top of it. Okay? You take our competitors and you drive over their housings, their tool with a half-ton truck, watch what happens. Oh, and you want to take it in for repair? You want to mail it and get it repaired? Huh. Watch what happens. Oh, no can do. It's a throwaway tool. You got to buy a new one. Huh? That doesn't make any sense. So, anyways, take care of these. They'll last you your lifetime, your entire career. Take care of them. And what happens is when you're ready to retire, You're going to hand them down to that apprentice, and you're going to show them how to take care of these tools, how to use them properly. All right? It's so important. Also, when you're using these tools, they all come with a hot stick adapter right here. Universal grip all right? You can use the metal ones. We got metal ones too. And these go, again, right on that. Make sure your battery's good. Your battery's good. Put on that hot stick adapter. Then what you're going to do is you're going to use the proper accessory on that cone tip. And we're going to talk about that. I'm going to go back here and pick up something. So all of our tools come with straight probe, hook probe, hot stick adapter. The bushing adapter, you're going through feed-throughs, doing some underground. The bushing adapter is optional. If you're working overhead and underground, make sure you're using that bushing adapter. I've done training around the country, and I've seen some folks, they're using probes without cover up. And they're going into that hot bushing just with the metal probe on primary. What if that metal probe without cover up, like we put on nice cover up, what if that primary potential, what if there was a bleed wire, a concentric nearby? What if? A static wire. Arc flash, man, full potential. No good. That ain't no good. Make sure you use the proper accessories. And you're going to put those right on the end of that cone tip. If you all are not using the proper accessory, the straight probe, hook probe, bushing adapter, and just using the cone tip, we call that a shortcut. And we're going to go more into that later in just a little bit, why you don't do that. That's a shortcut. It's an unsafe work practice. All right? The best work practices are to go ahead and use the proper adapter. Everybody got that? Any questions at all? ¿Tienen preguntas? I got to get ready. I got to go to Colombia and do training for those folks. I got to learn Spanish. Okay? ¿Tengo preguntas? No? Okay. All right. So, proper accessories, proper care. Simple. This equation, x plus y equals z. This equation, I actually want you all to take pictures, snapshot this slide. I want you to use this slide. And this slide here, I want you to train your line workers. I want you to train them this equation. I studied electrical engineering for 2.5 years, and they taught me all kinds of equations that today, I don't even remember any of them, okay? But this equation, you got to remember this one. X is the conductor. It doesn't matter if that conductor is energized or de-energized, X is the conductor. Remember that. Y plus Y. Y is tool functionality. How does a tool even work? That's what we're going to talk about. We need to explain the why and the how behind everything, all the components of the system, all the equipment, all the tools. We need to talk about the different bucket trucks. They have slightly different procedures and different bucket trucks. And we need to talk about everything so we understand. Here's how they work. The tool functionality is the tool makes contact with the X, the conductor, right here. The tool, the current begins to flow through the tool. It looks at that current, the tools do, whether you're phasing, whether you're looking at the potential. It looks at that current in relation to the ground plane. Always remember this. Always. That's a wireless. If it's a corded tool, they work absolutely the same principle, but instead of going through the air, the current through the air, guess what? That current is flowing through the tool, the cord of the tool, in relation to the ground plane. Y'all see that? You get that, young Simon? Okay? All right? So it's the same principle exactly. It's just you have air or cord. That's the medium. All right? So equals. Y'all need to always remember this right here. I want you, man, okay. If you don't remember anything right here, this is what I want you to remember right here. That Z, that's what we got to get to. We got to get to that equal thing called Z, because this is safety and accurate information gathering right there. All right? If we do not use the tools properly, if we don't understand the functionality of the tools, we may never have Z in our whole career. We've been doing things wrong our whole time. Hey, we never got hurt. It's the way I've been doing things. Oh, guess what? If there's a better way, if there's more understanding, more knowledge, then what's going to happen is you may finally get to the safety and accurate information gathering. We don't want just, oh, we're in phase. Oh, well, here's the potential phase to ground. Oh, we're going phase to phase. All right? No, we don't want to just get the answer as far as some number. We want to get Z equals safety. That's always been first. And if we've been doing them wrong, you all may not have been getting safety, just in information. And it might not even been the accurate information, the correct information. Wow, this tool's acting funny. Oh, the tool's acting funny? Maybe it's because you're using it improperly. And we're going to talk about that. Proper body position, proper tool position. It's so important. Fascinating, isn't it? Huh? This is fun. Anybody have any questions at all? Man. Okay. Everybody gets it. All right. So we're gonna talk about the line limit a little bit. We want to protect the line limit. And we're going to begin to talk about our second best friend here in just a moment. The line limit is a line about 2.5 inches down. About 2009, ASTM said, hey, we recommend you all put a line limit. And what's going to happen is that's going to remind folks, the line worker, when they're using these tools, that the resistors that help protect the tool and the lineman behind the tool, that line limit shows you where those resistors lie, which are directly behind that line limit. All right? So what that does is it takes that current and it squeezes the current. It adds resistance to the tool. Instead of having that full current, that full potential, what it does is it squeezes it and it makes it safer, the tool safer. So you're not getting primary to the tool, you're getting a percentage, a small percentage of what's on that X. Because you got to get something in order for the tool to let you know what that something on the X was. So it looks at that current and it gives you that voltage indication right there. All right? So protect that line limit. So what I want you all to do is you're going to use your imagination and you're going to use it and you're going to create a sphere. And you're going to take that line limit and you're going to take that line limit all the way under the tool, behind the tool, over the top of the tool, side to side the tool. And in that sphere, we're going to call her your air dielectric. We're going to talk about her a lot, your air dielectric a whole lot. She is your other best friend. I want you to take these principles as far as air dielectric and I want you to apply them in everything you do. Not just Bierer meters, not just using your phasing tools, not just. We want you to really get the air dielectric right here in your head and that understanding. You'll see why in a little bit, okay? So it's so important. Protect that. We don't want to see a cabinet close in to that because that's a ground plane. Remember, they're looking at the current relation to the ground plane, so they're energized with something. There is potential on there. There is current flowing there. We don't want no ground plane here. You're going to get high numbers, very high. They're going to be skewed, and they won't be accurate. And then what will happen is you could experience an arc flash. Huh? True story. You could. I was on the way to do some training for a large utility in Texas. And on my way to that utility, I was in Louisiana, and the safety man calls me up. They call them safety reps at this place. He called me up, and he said, hey, man, we were using your tools. We just had an arc flash. And it's like, man, I'm one day from being there, giving them training, and they have an arc flash. One day before I get there. It's like, what the heck? So anyways, I said, hey, send me the picture. They sent me the picture, and guess what? You probably already can figure out what happened. Yeah, they were using it. They had a feed through, and they had a static wire right next to the meter head. arc flash. Lineman's fine. Lineman's okay. But they didn't get what you're getting now. They didn't get line worker safety tool competence. They didn't get that. Now they have it and they don't ever call back. It doesn't happen no more. And we're going to talk about how to mitigate that, because sometimes you can't help but having that cabinet nearby. Sometimes you can't help but having that other phase, your switching cabinet or something, that other phase is going to be nearby. Sometimes you can't help yourself. That's just how it is. But we're going to show you how to fix that, how to mitigate that. Okay? We got a question.
Yeah, and the GT600 test grounding elbows.
Absolutely. So the GT600, thank you for the question. The GT600, actually, this accessory right here is built for clamps and it's hollow. So you can get these that take care of the 35 kV interface elbows, and you can get them where the brass inside inside, what do you call that, ID, inside dimension, where the ID is good for 15-25 kV interface elbows. Okay, great question. Test everything. You could test. You could test flat clamps. We have flat clamp accessories. We've got the big, huge brass round pieces that you can test your transmission grounds, substation grounds. We got everything. Okay, everything. All right. So ask questions. Okay, I don't even know what we were talking about. So protect the line limit. Make sure you do that. Keep your air dielectric. That's important. Short sticking. All right, so this is a big item out here in the field. And some of you folks might have seen this, might have heard it, and maybe in your younger days, before you learn a better work practice, it's possible that you were using your tools by short sticking right here. It's possible. I know some of you might be smiling right now. That's typical. I get this where they start smiling. They start looking at each other, because guess what? They were just doing short sticking yesterday. And they know it. All right? So we don't do short sticking. Short sticking, what happens is, one, you're getting into the air dielectric. Maybe you're wearing gloves. Maybe you're not wearing gloves. Don't short stick. You're getting into your air dielectric. We recommend you're 36 inches back on your stick. If you don't wear gloves, that's great. You're protected. That stick is insulated 100,000 per foot. These sticks are 100,000 per foot, just the same. All right? So get back about 36 inches. We want you to have electrical tape. We want a hand guard. Whatever you have, make sure you get 36 inches back. And by having something that can be seen, your groundman can be watching the apprentice up in that bucket truck and verifying, because they're a team, verifying that they are indeed 36 inches back. You want to protect that air dielectric. Why? Where are your bodies from? Huh? Your bodies are what? Wait, the current, the potential is looking at the ground plane, and your bodies, you're wearing a dirt and water suit. A dirt and water suit, a temporary dirt and water suit. You are a living, breathing ground plane. Not who you are, no. It's your tent. It's what you're borrowing. All right? And we don't want that potential. We don't want that potential to be looking at you. Let it look at that ground. So keep your air dielectric. Again, air dielectric, your best friend. Make sure you keep her. So no short sticking. Also, man, this is so important. You do not want to be tool glover. You don't want, as a lineman, man, don't be doing this with your tools. Tool gloving. That's a horrible nickname to have if you're a lineman. Some of you guys will figure this out. Some of you won't, but it's a horrible nickname, and we don't want you tool gloving. All right? So what happens is, you remember that equation, x plus y equals z? When you're short sticking, if you're tool gloving, you're part of x plus y plus u, and it never has equal safety. Nope. Never has at all ever equaled safety. It never has ever equaled accurate information gathering. This is improper body position. Flat out. Tool gloving. Years ago, I was doing training at a large utility in California. And when I was there, the guy one of the linemen came up, all gray haired. He's about 25, 30-year journeyman lineman. He's been in the trade for a long time. And he came up to me and he told me, thank you. He said, I went to a capacitive test point, and when I did, I forgot to wear my gloves. And when he went to that capacitive test point with his bare hands, what do you think he told me? What do you think he told me that happened? Anybody respond, Jeremy? Not yet? What do you all think he told me? You know how electricity works? You know how everybody's tools, whether they're ours or somebody else's, you know how they work. You know they're energized. So when he went to that capacitive test point, he got popped. Freaked him out a little bit. No one ever told, now think about this, large utility, no one ever trained them that when you're using these tools and you're touching that X, no one ever trained them on the how and why of the tool functionality plus Y. No one. He did not realize ever that the tools were energized. He never was trained that. How many other linemen in this large utility, hundreds of linemen, how many of the others may have inadvertently done the same thing? You know how guys are. We forget stuff. Sometimes, why do they call us sheep? All right? We follow this guy right off the cliff because all the other sheep are going off the cliff. Sometimes we just don't got it together. And how many other linemen, if there's hundreds, over 20 years, did the same thing? I don't know. But you know what's interesting? Let me ask you all a question. What's interesting in this whole thing is, and I find this fascinating, is he didn't share with anybody. He didn't share this incident with nobody. Why? Fear? Maybe he would be mocked. Maybe they would put him to shame. Maybe he could lose his job, get fired. Maybe he'd be demoted. Huh? Think about that. He could not share. And the reason why he could not share, I want you all to remember that, is because their system, they did not have a house of safety that had capacity built into it to where he could fail safely and share it, and the other line workers in that whole utility could learn something from it. Think about that. If we're supposed to be our brother's keeper, our sister's keeper, we're supposed to be, but if we can't share an incident, how are we our brothers and sisters' keeper? I don't get that. We cannot share an incident. Why can't we encourage sharing incidences? Why can't we, instead of giving shame to somebody, give them high fives? Thanks, brother. Thank you. Your mistake is going to save me. Your mistake is going to help me, and I won't redo that same mistake. It won't be 2.0, a sequel. All right? You guys ever see that? Sequels? I mean, Star Wars. I think they're on their 24th episode now in Star Wars. Okay? So anyways, so just remember that. Share these events. And I guarantee you, you may have a uptick in hearing what's going on, and it may sound kind of scary and kind of sketchy out there, but I guarantee you, if you are honest with one another, it builds trust. You start learning and you start believing in one another, and I guarantee you, those things are going to start dropping. Okay? Dropping. All right? So no short sticking, no tool gloving. Let's talk about proper body position. Let's talk about proper tool position. So when you're working hot, this is crucial. This is so important that you're using your products right, that you're placing your body right. Make sure you place your body right in the right position. Okay? So we're going to talk about this. We got a corner pole. See this? Jeremy, can you see this? We got a corner pole right here. Okay? That's a corner pole. And I get a call from a journeyman lineman. Not only is he a journeyman, but he's the lead lineman for this utility, Illinois. And he says, hey man, I'm using your analog and I'm getting 13,000 volts. I'm only on 7,200. Well, Being a lead lineman, you don't want to argue with them on the phone, especially not face to face, because they're always right and you're going to be wrong. So I said, look, I'll come out there, I'll get a plane ticket, I'll fly out there, I'll give you some line worker safety and tool competence, and let's go back out in that same scenario after the training, and you're going to use that broke tool, and let's see the results. And he agreed. I was out there in a couple weeks. So here's this corner pole. We got 3 phases in front. We got 3 phases to the side. I'm in the bucket truck. He goes up, gets in that bucket truck. He gets his analog meter. He makes contact with that conductor, and he's getting about 7,300 volts on 7,200. Pretty darn accurate. Huh? Pretty darn accurate. He got out of that bucket truck. Lead lineman, mind you. And this was good. He came out of that bucket truck and he proceeded to tell me everything I already knew was happening when he called me. Because it's real easy to understand that 7,200, if you're out of phase, phase to phase, out of phase, you're going to be real close to 13,000 volts. And he was using the wireless analog. So he got out and he said, hey, when I was up there a couple weeks ago, I was using it like this. Short sticking. Think about it. He's in the bucket. When you short stick it into the bucket, you're a lot closer to that primary. Dang. You're not protecting your air dielectric. You're kicking your air dielectric to the wayside, your best friend. Try doing that a lot. See what happens. You start kicking your best friend to the wayside. Not going to be good. Okay? Here's that corner pole. He's short sticking. He's got his back to the enemy. When you're working hot, we need to train our folks that energized conductor or conductors are our enemy. Okay? When you go home and you turn on the lights and you give your spouse a nice big squeeze, that electricity is a blessing. But when you're working hot, always consider that electricity that you work with an enemy. Anybody here ever see ready kilowatts? I call them ready to kill a lot. Okay, that's another session that I train. And I tell you what, if you ever see that ready kilowatt, he's got a gangly lightning bolt body with a knife in his hand about to kill this little kid. Huh? And he looks like right out of a horror film. And I tell you what, you lose an arm, you lose a leg, you don't go home that day, your family, you're going to experience a horror. It is a horror. Remember that. If that's the truth, that electricity, when you're working hot, is your enemy. He had his back to the enemy. Short sticking. Improper body position. 1, 2. And what happened was, when he was looking at that potential, that phase behind him was coupling capacitively with his body. It was flowing through his body, across his gloves, through the tool, the opposite direction, which they will do that. And the tool was making contact with X, and that current was flowing through the tool the proper direction. So literally, he was phase to phase out of phase. He was a living, breathing, wireless phasing tool. All right? So I want you all to remember that. But when he created that air dielectric, he had his front to the enemy, which always keep your front to your enemy. Why would you put your back to your enemy? And he was back on a stick, so he had his air dielectric times 2. Not improper body position times 2, but air dielectric times 2. And he got what? Whoa, wait a minute. He got that equation, X plus Y equals safety and accurate information gathered. Huh? Maybe by now some of you guys and gals, maybe this is starting to click a little bit in your mind. That's good. Okay? Remember that. Proper tool position. When you're using these tools, you always want to make sure that if you have a vertical stack, you're going to go into that, say, the middle phase. You're going to go into that middle phase to where you're perpendicular to the lower phase, you're perpendicular to the higher phase. And the tool is also perpendicular to that long source that you're making contact with, the X. Okay? So what happens if, remember that phase to phase, remember that lead lineman, what happens if we bring our tool where it starts coming down to that lower phase? Oh, will the numbers go up or down? Let's see what they say, Jeremy. Will the numbers go up, higher, or will they go down, lower? Una pregunta por ustedes. Well, you're getting close to that other phase, right? So you're phase to phase, and you're out of phase, the numbers go up. Remember that. If you're by a ground plane and you're in you're up in that overhead, and you're near that corner pole, or you're near that pole ground, is it possible that because you're way above ground, but there's a pole ground near your meter? Okay, so your distance is actually not to this ground, but to the pole ground. Will that meter start reading a little higher? Yep, it'll read a little higher because our tools, you say OH, overhead. You're telling the tool you're far from the ground plane. You got URD, you're telling the tool you're close to the ground plane, right? If you're overhead and you're close to a ground plane, let's say you're in a substation and you're doing some substation work, and you've got a lot of equipment, you've got a lot of structure all around you. You may want to put it in URD because you're close to ground planes. It'll be more accurate. All right? So, horizontal stack. Same thing. You're going from here to here. That's all. Same principle. All right? All you got to do to understand this is turn your head sideways, and then you'll understand. All right? Y'all get that? So, if I'm at this long source and I start bringing the meter, I don't have that 90 degree, I'm not perpendicular to that same long source, and I start bringing that meter where it's parallel to that long source, what happens to the numbers? What happens? Well, you get closer and closer to the same potential. So your numbers will go down. Absolutely. Remember these things. And you can experiment. There's nothing wrong with going out and experimenting with your tools. In other words, do that to some degree. Come in to where you become parallel, you're with that same source, and watch those numbers go down. Experiment. That way, once you experiment how not to, you'll know what's going on. You'll know what's going on with those numbers when you're out in the field. If they're too high, too low, you're going to learn what's going on. Because remember, these tools are so accurate, you actually can do line worker experiments. So experiment, learn. It's pretty cool. So proper tool position, proper body position. Any questions thus far? Anybody have any questions? Everybody good? Okay. Y'all can email. We've got a lot of resources. The ECOS, the Electriculture Safety, Lineworker, Safety National Webinars. This will be 6066. You can email me. I'll send all of them to you. Go to Electriculture of Safety. Go to Bierer Meters YouTube. Go to the playlist, and you can go to Electriculture of Safety promo videos. Go down that playlist, find the speaker, find the topic, and if that's what you want, that's what you get. Just ask for it. So simple. There's no cost. We pay for it, Bierer pays for it, and these folks that come in, some of these folks actually pay for coming here and speaking out of their own pocket personally. I'm very serious. It's an amazing thing. Okay? All right. So these 5 steps are really important. A lot of crews are actually going to this. Their best work practices are changing over to the 5 steps. OSHA 1910.269. Typically there, it says to use your tester, whoever you use your tester and verify an absence of system voltage, your nominal voltage. All right? So we're going to talk about that. This is really good, the 5 steps. And a lot of utilities and contractors are bringing this into their work practices, their work methods. And we just had a huge utility in Texas very recently that took all their stuff out after this training, and they implemented this for one, and some other things. They implemented this into their best work practices, because guess what? The training that we shared with them, the Lineworker Safety Tool Competence, challenged the status quo. Things that they were doing for decades after decades, that training challenged their status quo, and they allowed it to challenge them, and they made changes. So that is so amazing, and it's a beautiful thing to actually do this. And then years later you hear, or even months later, that changes were made, that they're starting to inspect their TPGs, they're starting to electrically test their TPGs. They never used to before. Now they are, because we came by and gave them some training. And that feels good. That's a good thing. So tens of thousands of linemen, I mean statewide, a lot of statewide have made changes. So tens of thousands of linemen are safer today than they were 9 years ago. And that's awesome, okay? So we're gonna talk about this. Test, open, test the tester, ground, 5 steps. So in the 1910.269 lowercase n, they talk about how you're using your tester to test for potential. The lines, it's open, test, ground. That's typically how we work this. Open, test, ground. But hey, we got to test our tester on a live known voltage source. Whoa. So if we got to test our tester on a live known voltage source, hey, whoa, Johnny, we are not going to open that switch. Nope, we're not going to open it. We're going to leave it closed, and we're going to use our tester, and we're going to test it, make sure the tester's working on a live known voltage source. There you go. That's so important. Well, so that's test. But we'll also, there's a couple things here. 3 things. So we test on a live known voltage source. 2, you're going to verify that your tester is calibrated. Oh, wow. So you can do that at the same time. As long as you're using it properly and your body's in a good position, you can verify that your tool's pretty accurate on that X, on that system voltage that you expect or you know that's there. So if your tool is accurate for 20 years, how many times should you calibrate your tool? We recommend once a year. As a manufacturer, we got to say something, right? We have to. But if I'm testing my tester and that thing for 20 years is accurate, I know that it's calibrated for 20 years. So that's the second thing. The third thing, and to me, this is the most important thing. Remember we talked about building that house of safety. This is the most important thing to me, is that when I'm out there with my pole buddy, we'll just call him Johnny. For whatever reason, that name kind of stuck for today. So Johnny's out with me, and when we go hot, what we're gonna do is that first thing, test, right there, is we're gonna test each other. What do you mean? I'm gonna ask Johnny if he's got my back here, because we're gonna get down to some nitty gritty on this job site. This is after the tailboard, right? So we're gonna get down to the nitty gritty. Do you have my back, Johnny? And Johnny's gonna give me a verbal. I don't want no head shake. I don't want no nod in the yes configuration. It's not what I'm looking for. I want to hear words. Yes, I got your back. I want to hear words, because that right there is a covenant. That's an agreement. That's a covenant. When you speak words, they're powerful. So I want to hear some words. And then Johnny's going to ask me the same question. He's going to ask me if I got his back. And I'm going to give him words. Absolute. I don't even like Johnny. Okay? I don't like his grooming. I don't like how he doesn't shower as often as maybe he should. And he doesn't like me either. I got all these tats, and he doesn't like tats for whatever reason. So we're not too friendly with each other. But guess what? When we're a line team, we're out in the field, every team is in it to win it. And you might have some people on your line team that you don't appreciate so much, but you're still in it to win it. And when you're in a line team, you're going to perform at the best of your capabilities to be your brother's keeper, and he's going to do the same to you. Okay? And that's just how it is. So yeah, I got his back, and he's got my back. So that's why we test, and we do it for those 3 reasons. Open. Now we're going to go ahead and open that switch. All right. After we open, we're going to test again with our tester. All right. So how do you know your tester was working 100% for sure? We're going to take a few extra seconds, and now we're going to test the tester on a, on a live known voltage source. What? Yeah. So what we're going to do is, we have our 3 kV power supply. We've had this for a long time, many, many years. This is great. We suggest these, use them for corded tools. You have phase, that little button you push down, and you have ground. We suggest this for corded tools. This here, you got a Milwaukee battery, and you pop that in, and this thing puts out 3,000 volts. It's a live known voltage source. We're not rubbing on our shirt, getting a little bit of static. Nope. We're looking for real electrons. We want electrons that are high voltage. We don't want our electrons coming off our little shirt. We touch a little piece of metal. Maybe your boat trailer, you're going to get your boat out real soon. You go buy your boat trailer, you took off your tarp, covering that trailer up to keep it nice for the winter, but you're ready to get a tan lines, and you get that boat ready, and you go by after you move that tarp off your boat, and you touch the metal tongue of your trailer to get ready to put it on your truck, and you get shocked a little bit. That's not high voltage, folks. That ain't going to work. Okay? So you're going to get 3 kV power supply for your corded tools. We have a handheld power supply for your single point devices, your wireless. How's that? Handheld. Let's see what that looks like. All right? Let's turn this on, 3 kV power supply. We're going to put it in URD because we're close to the ground plane. It's going to be a little high. We got some metal table here, so it's going to be a little high, and that's okay. All right, there you go. High voltage. We got a handheld. I'll turn that off. We got a handheld power supply. Okay, right there. About 2,000 volts. Actually, it puts out about 1,500. What do you think, Joey? About 1,500? Okay. And so it's getting about 2,000. My hands are close to it, as you can see. These are low current devices, low power. They are very safe. You can take this tool, the handheld, and you can put it on your skin. I don't recommend it. Don't do that. And you'll be fine if you turn it on. That 3 kV power supply, about 3,000 volts. Low current, low power, very safe. You won't be happy. Your hair may be a little curly afterwards, but you won't be happy. But it's safe, okay? Use them. So, always, right here, test, open, test. We just tested the tester, and what we're going to do is now you're going to put on your TPGs. So you want testers. Now think about this. Just hold on just a minute here. If you're using your tester, lowercase n, TPGs, number 5, and you're verifying an absence of nominal voltage, huh? Now just think about this. Why would you use a non-contact tool? Why? You're on the underbuild. You've got capacitance everywhere. You've got backfeed possibly. You've got some coupling. You've got some induction, huh? For sure. On that line to some degree. Why in the heck would you use a non-contact tool? You're trusting the tools with your life. If you're using non-contact tools, here's what I want you to do. And I taught this at an electrical contractor several years ago, and they haven't had me back because it cost them a lot of money because they had to do what I'm about to say to you. And they did, okay? What happened is those tools will give you false positives, false negatives all day long. And if you're going to that X and you want to ground the X, you're verifying that conductor is de-energized. Why would you use something that's not touching X? Huh? Think about it. When you go home to your spouse, you go home to hug your kids at night. Are you hugging them? Air hugs? Air hugs? Are you kissing your wife with an air kiss? Huh? Try that. You just try that for a little while and see what happens with your marriage. If you're not touching that conductor, and trust me, she'll conduct if you want her to. If you're not touching that conductor, I'm going to tell you something, you're not living real, okay? We want you to throw those non-contacts away. And in South Carolina, we have a phrase that we use that I didn't know until I moved here 11 years ago. It's called chunk it, okay? Chunk it and get you direct contact. Any questions, Jeremy? See if we have any questions. Huh? Nothing? Okay. Any concerns? No? So remember, concerns are a prediction of an unwatered outcome. If anybody on that crew has a concern, we want to train them that they can speak up. They need to say something regardless. Stop work authority. We need to stop the work. We need to grab a hold of each other, get the attention of each other, stop the work, and we need to have a line huddle. Okay? We need to have a line huddle and talk about that concern. If it's a concern with one person, that groundman, he's only been on the job for 2 months. He's seeing something happening, and to him, it's a great concern. And you all better listen to what he's about to say, because it could save your life. Maybe you got a little complacent. He's not complacent, he's fresh. He's got fresh ideas, he's just learned some fresh stuff, and he's saying things that go against what he was just trained in that training yard. That somebody else, that journeyman lineman, has gotten complacent and he's been doing for years. We want that fella or that gal to speak up. Okay? So let him speak up. Here we go. Zero ohm extension, arc flash, prevention, mitigation. All right? So if you're using your tools, remember that air dielectric. If you're using your tools, you do not want anything in that air dielectric. Why? Because you're always going to protect your best friend. You don't want to get close with your body, with a conductor, with equipment. You want to protect that air dielectric. Get away from that conductor. Put that conductor in front of you. Put some space right there. Okay? And what we're going to do is we're going to go ahead. We inspected our area and we see that we have a vault, a tight cabinet, or we see that we have some phases nearby. Maybe we're working in the substation and we're seeing that we have some another hot bus next to that phase, that X that we want to make contact with. So what we're going to do is we're going to mitigate that situation easily. So what we're going to do is we're going to go from this scenario where that hot bus is inside our air dielectric, and if it is, we don't have air dielectric. You just kicked your best friend to the curb. But we're going to use a zero ohm extension, and we're going to go ahead and this happens. Or maybe you have a tight cabinet. You get on that, or a concentric. You put on that zero ohm extension, bam. You'll never have an arc flash. Y'all get that? You understand? You can use 2 of these on, if you need 2 of them. On your quarter tools, if you're in a tight switching cabinet and you got to take the secondary probe and you're doing some phasing or whatever in your secondary probe, like we have here in the ground, you get that secondary probe right there, put a 0 ohm extension on it and on your meter probe. All right? Y'all get that? So mitigate that. It's important. This is a training video we have at Bierer Meters YouTube channel. Just go down the playlist, look for safety training, and you'll pick this up. And watch it. It's very important. Again, always use the proper accessory on the end. Always. Okay? Any questions, Jeremy? Good? Okay. All right, so let's go ahead. Corded phasing safety. So I get this call about, 6 years ago. Large utility, a big cooperative in Texas. A lot of things happen in Texas. Not that they work unsafe, But Texas is huge. All right, so they got a lot of utilities, a lot of contractors. That's why a lot of things happen in Texas. All right, South Carolina, shoot, it's probably what, 1/20th, maybe 1/30th the size of Texas. Nothing happens here because there's hardly any people that live here. So that makes sense, see? So your corded phasing safety right here, whenever you're using these tools, you might have heard that trash truck. This is live. Hear that? He's doing a good job. Okay, I think he's done. All right, here we go. So the corded phasing safety, remember that potential, that piece of potential and that current is flowing through the cord. Y'all remember that. So when you're using these cords, always use these cords 36 inches away from your foot. Try to keep it 36 inches away from your leg. You're in the bucket truck, try to keep it 36 inches away from your body. Always, because that current is flowing through that. It's energized, going to that secondary probe. Whether the secondary probe is going to ground or whether that secondary probe is going to another phase, it's energized. So it's part of the tool. The cord is part of the tool. Remember? Keep away, keep your air dielectric, same thing. Get away from the cord, same thing. So we get a call from this utility, and what happened was the linemen were in a substation and they made contact with X. There was a hot phase right in full primary potential. Resistors are here. There's a hot phase here. There's no resistors between that hot phase and the meter head. Full potential, popped that meter head that flowed down the cord to that secondary probe right there, and it blew up at that secondary probe. It blew up at the meter head. The tool, when it all came down afterwards, the tool actually functioned after this. I couldn't believe it. We had to clean it up a little bit, but it actually functioned. But anyways, they called us and they said, hey, we had an arc flash. We're starting to lose confidence in your tools. We're thinking about going to another manufacturer. Right, okay, that's fine. Show us the picture. Sure enough, they showed us the picture, and the hot bus was over here on the right side of the meter. If you're looking at the meter head, your lineman using it, that's what happened. The picture was here, and that equipment, that hot bus, you could see the explosion that happened here, and there was like a moon crater on that gray paint of that equipment, and the hot bus is here. All right, so what happened is they didn't have line worker safety and tool competence like you all. They didn't have that at the time. So I said, look, just hang on. I'll come out there and I'll give you some training. And then you guys make that decision whether to go with another manufacturer after the training or not. I went out there, and when I went there, the two linemen where this incident took place were there. That's a good story. So this is a good story. All right, they were actually there and able to tell me the story. They brought the tool, they brought the cord, it was all in pieces, blackened. It was like a bad Southern barbecue, okay? And so they brought that in there, and they told me the story. And the story was when they had that arc flash, they dropped the tools, everything they had, and they went running, screaming too. That's what they said, all right? So anyways, what if when they were using that tool, what if they did not train? Now think about this, that their linemen, their line workers, were supposed to stay away from that cord 36 inches. What if that cord, when they were using it, they were going phase to ground. What if that cord was leaning against when that full potential blew up and flowed through that cord lickety split? What if that cord was next to one of those linemen's thighs? You heard of step potential? The higher potential's over here, but it's lower on this leg. What do you think would have happened? If they survived, they may only have one leg, maybe none. If they survived, maybe they would die. So they train properly. They train safe to keep their distance from the cord. Now, a lot of folks are using these corded tools. Now, I want you all to think about this. They're using the corded tools, and the corded tools, might be on a situation to where they roll up, making coils. Remember this, maybe they're using a corded tool that when they're using it, however they're using it, they're in that bucket and that cord is next to their body. Now, just think about it. That's all I'm just giving you food for thought. But here, this cord here is shielded at 35,000 volts. We are the only company that I know in the world that actually creates a shield within a cord or outside the cord. A cord within a cord, how's that? And we put extra time, extra resource into this because we can. Because we don't have stockholders, we make our tools safer. We put more money in our tools, and this cord is shielded. When you use this tool, the PD25 or PD50, when you use this tool, you can have this tool where the cord is on the ground. You're phasing across a box. It can be laying on the box. It's safe. Maybe you're in the bucket truck and the cord inadvertently comes in contact with another phase or the neutral while you're using it. It's okay. It'll be fine. Just make a little adjustment, get it off that neutral, get it off that other phase. It's okay. So just remember these things. It puts a little more safety in your house of safety. Remember what we said? We're going to build our house better and bigger than ever. We're going to handle any storm. Okay? All right. Any questions? Any of you all folks have questions? All right. So we're going to talk about energized line worker coupling with capacitance. Our production manager, Mr. Joey, is going to help me in just a minute. And this is kind of his first time helping me out. This is going to be cool. Joey Pelliter, he's a great guy. And he's just a wonderful production manager here at Bierer Meters, and he runs a tight ship. And he's created a Bierer team, a Bierer line team, and it's a neat thing what he does. But I want to talk to you guys about something. This tool here, the PD25, the PD50 series, this tool is true RMS plus or minus 1%. No other tool like it. And that's actually true. This is one of Walter's 17 patents. This tool here, true RMS, you can high pot with this tool. You can de-energize capacitance. You can de-energize capacitors. You can also verify your regulator neutrals in the neutral position. You can test lightning arresters with it. You can go phase to ground, phase to phase with it. You can use a phase sequence adapter, and you can verify the leading phase in the field and your rotation in the field with this tool. It's pretty cool. You can also, with a DC 100 battery pack, you can also identify cable new construction. What you do is you put that 100 volt battery pack on your secondary probe, you take the meter probe to the other side, and when you see 100 volts, because this reads AC and DC voltages, when you see 100 volts, guess what? That's your cable. So you can do a lot with this tool. It's what we call multimeter. But there's another functionality of this tool that folks really need to get a hold of and grasp. And that is, this tool is a great training device. That's why we use it. We use this tool for a training device. So if you're gonna, you guys ever heard of scientific experiments? Well, you can use this tool here, the PD25, PD50 series. You can use this tool for line worker experiments. Seriously. And you can, when you're out in the field, you could actually get underneath the transmission line, hold this up, and you can look at voltage that's in the air right above your head. I've done it with my wife. I took her out, we went walking, because she didn't believe me that I was about to tell her. I told her that, hey, when we walk down, do our little walk in our neighborhood, and when we walk underneath those distribution lines, you are being energized. And she's not a line worker. And she's like, you're crazy, no way. So I take the PD25 line worker experiment. I take the PD25 with us on our walk that day. And we got to that distribution line. I told her to stop. We're right off the edge of the street, which is the normal place we walk. It's a safe street, okay? We don't have sidewalk, but it's safe. And I took that tool, I put it together, I went to ground with the secondary probe, and I held this near her head. Okay, she's a little shorter than me. That's a good thing. She's a little shorter than me. and I'd put it near her head and check it out. There was 6 volts right by her head, not above her head, by her head. There was like 3 volts here in the ground, just above the ground, and there was 6 volts at her head level. She freaked out. Not only that, but you can use these for line worker experiments. When you're in a substation, when you're in a bucket truck, and you can just verify what's going on. When a line worker is working unsafe and they're getting into the mad, watch what the numbers say. When they're out of the mad, watch what the numbers say. When they're working, today's a nice dry day here in South Carolina, but if it was real humid, we had rain just a few days ago, so it's kind of squishy. If it was real humid, these numbers you're about to see, and Mr. Joey's going to help me prove them, these numbers would actually be a little higher, okay? So I always like to train folks that when they're using these tools and it's a real juicy, humid day, moist day, a little foggy day, I always tell them to get, you got your mad, I always tell them to get madder. Seriously. And when you use this as a line worker experiment, you'll understand why you want to be a little madder. We'll talk about that. Okay? You ready, Joey? Come on in. Come on, man. Yo, brother. Okay. There's Mr. Joey, folks. Production manager. Does a great job. So what we're going to do is we're going to take this 3 kV power supply, turn it on. And we're going to look at the differences in the voltage on my body. So whenever you're working hot, if you're safe or you're unsafe, you know what, Joey? I'm going to have you do this. I'm going to have you do this. If you're working, go ahead, Nick. If you're working safe or unsafe, you are coupling capacitively with your job when you're working. That's a true fact. Well, check this out. This is amazing. Again, line worker experiment right here. All right. You ready, Joey?
Sir.
Okay. So Mr. Joey, he's got our VD1000X. This is my favorite. The VD1000X is my favorite wireless single point voltage indicator, voltage detector. It's my favorite. The reason why is because the X stands for secondary. So you can use this all the way up, direct contact, remember that. You can use it all the way up to 999 kV transmission. You put it in URD, it goes to 99.9. You go to OH, overhead, it goes to 99.9. But it has a little position called the X, which is secondary. And check it out. It is very accurate on all your secondaries. And capacitive test points. Whoa, that is a great tool, okay? Anyways, so Mr. Joey, go ahead and press down on that. I'm going to go take this tool to 2 kV. 2 kV, this tool, here, show them this, Simon. 2 kV, this tool is accurate from 1 volt. It starts working at 1 volt. Great for line worker experiments. Starts working at 1 volt and it goes up to 2000. So we'll put it in 2 kV. And Mr. Joey will go to his shoes. And what do we see? 1 volt, Mr. Simon. Okay, 1 volt. So Joey's working safe. Come on back a little bit more, Joey, on your skit, about 36 inches. There we go. Let's do it again. About 1 volt. So he's working safe and he's coupling capacitively with his job. Okay? 1 volt on his back. Let's go to his glove. Inside glove. 0. Okay, that's cool. All right, Joey, go ahead and short stick. Be a short sticker. He's working unsafe. We're still getting 1 volt. Getting no volts, huh? There's 1. Trying to get to 1. All right, inside glove. See that, guys? 5 volts. All right? All right, Joey, go ahead and tool glove. Tool gloving, Joey doesn't have the hot stick. He's got the hot stick adapter. So he's going to tool glove. Here we go. 2 volts, a little higher. Go to his back. 3 volts, a little higher. Go to inside glove. 6 volts, a little higher. Y'all see that? So he's working unsafe. So you always want to work safely. Joey, go ahead and put it back down and come back on your stick. Get that air dielectric back. Press down. Okay, so here we go. So we got that source right there. Now we got Joey's head right here. Okay, so we're clean. We're good. 0. Okay. Oh, there's 1. See that, Simon? There's 1 volt. Let's go in the air. See that? 5, 6, 7, 8. Huh? 12. Look at that. Right there. 16. Get closer over here. Remember, it's flowing through the tool, the current, so it's going to be hotter here. So there's close to 100. Let's go to the stick. Now remember, the stick's insulated, but that voltage is flowing through the air, kind of around that stick, isn't it? Look at that. Look at that. See that, Simon? Y'all see that? That's why you want to get back on your stick, and that's exactly why you want to be away from your job, away from your work, and that's exactly why you want your air dielectric. Exactly why. All right? Very good, Joey. Thank you, sir. That's perfect. All right, so I want you to all remember this. Here's a situation. Here's a scenario took place. I was doing training at a state. I don't even want to name the state. And what happened was, this is like when I first started realizing we need to stop showing off our tools when I travel, and we need to start training safety, because these folks, they're not understanding their electric reality. And so what happened was, there was two linemen. This was 9 years ago. 2 linemen were working, and they were working on a cabinet, elbows, and that cabinet was loose from its foundation. Just remember, you need a good foundation in your life, all right? And they were working on this cabinet, and what happened was, is one lineman was back on his tool, his stick, hot stick. He was back on his hot stick, working those elbows, and the other lineman, he had his gloves on, and he walked over to that cabinet with his gloved hand, and he put his gloved hand on that cabinet. It was a summer day, hot, moisture, and humid. And when he put his gloved hand on that cabinet, that energized source, that capacitance, flowed across his glove. It's insulating, but he's a ground plane. It had enough capacitance on his body that it arc flashed him. He's all soaking wet from the sweat, but it arc flashed him across his glove. And what happened is they did an incident report. And in that incident report, true story, they said the reason why that happened is because of rat piss on the cable. That's it. That's their story, and they stuck with it. The truth was swept under the rug. The truth of the matter is that he coupled capacitively enough with that source, because it was wet, moisture, even with his gloves on, it still found home. And those electrons, when those electrons start seeing home, and we proved it, Mr. Joey proved it, when those electrons start seeing home, they get excited. When they get excited, they start partying. They start having a little party. They start giving each other high ready kilowatt 5s, and they start thinking they're all going home. And when that lineman with his gloved hand, when he put his gloved hand on that, he should have got madder that day because it was moist. And he should have allowed more capacity in that house of safety at that moment. It should have been taught. He should have allowed for that and never have done that. Okay? He survived, didn't lose any body parts. But anyways, the story is here, you guys need to think about all these things and that you are energizing with your work. It's so important. So I told those linemen that report was a escape rat. And what happens is when they make excuses for the true root cause, what happens is we don't learn nothing. And these events keep taking place. We need to understand our electric reality as far as the noun, the thing we're working with. That's the noun we're working with. We must understand it. Okay, I want you all to check out this. This is my family several years ago. My daughter wrote me this. This is still in my office to this day, right here. Okay, but you got it. This right here, this is why I do this. For you all, okay? We don't charge for this because we care. We give back. And all these folks at ECAUS, Electrical Culture Safety, they do the exact same thing. Line team, right here. No life, no task is more valuable than a human life. No task. Zero. I don't care what it is. You got a work order. That work order is not the main thing. The main thing is right here. What is your why? That's the main thing. Right here. Working as a line team. That's the main thing. That work order, you're going to replace that broke pole? That's not the main thing. This is the main thing. Working as a line team is a condition of employment. Does your employer have that as a condition of employment, that you have to be a team? Do they? Did they talk to you about that? Do you want to change some of your condition of employments? Do you want to change those? Because you probably have some written up that you go over, but you think you should change and maybe make it the team, a condition of employment? Because if you're not a team and you go change that broke pole, that's a hazard. And that needs to be recognized. It needs to be talked about on that job brief. If somebody's got something on their mind, maybe they got in a fight with their spouse because they're too far in debt and he or she made some mistakes. That line team out in the field is not a line team at all, and that's a hazard. We need to recognize these things, and we need to embrace one another, and we need to keep that lineman oath to one another, that covenant to one another. And you don't have to like them, but you better have their back. And they don't have to like you, but they better have your back. I appreciate everybody. Contact us if you have any questions. I can send you our Lineworker safety work tool competence workshop. It's about 8 pages long, and you can take that workshop, you can use it, you can edit it, you can take it and use it for yourself, or you could design something to where we come out and we do it. I would highly encourage you all to have that workshop curriculum, because it would help your curriculum, no matter how your curriculum is worded and no matter what you all train. Because what we need to start training is right there. Thank you all. You all have a good day. Be blessed. Thank you. Bye-bye.